Hey everyone, Mrs. Jones here. Just wanted to make some notes for you all so you can understand what parallel lines cut by a transversal with algebra really means. Basically, this is exactly what we've been doing for the past few weeks, except now there's going to be variables involved. So a little bit more mathematics. Let's start by reviewing some vocabulary. First, let's talk about transversal. Again, transversal is just the line that cuts through the two parallel lines, okay? And it makes two intersections in the diagram. Next, we have corresponding angles. These are two angles that lie on the same side of the transversal, and in similar positions, they're just in two separate intersections. So here we have the one angle, and we'll call it the top right corner, and then in the other intersection is the other angle, also in the top right corner. These two angles will be equal in measurement. Let's go to the next one. We have alternate interior angles. Alternate meaning opposite sides of the transversal, and interior meaning inside. So here we have two angles inside the parallel lines, and I always think of the letter Z. It's the two angles inside the letter Z that's formed when the transversal cuts through. I'll show you what I mean by the letter Z. Here, I'll make it in green. It's like a capital Z. And alternate interior angles are inside of that. Those are equal angles. Alternate exterior angles are also equal. Here we have the angle here on the outside of the parallel line on the right of the transversal, and here we're on the outside of the parallel line on the left. Those are equal in measure. We have supplementary angles, which are just two angles that add up to 180 degrees. Here we go. We have this angle in green, and then the next angle in blue. Those two angles add up to 180 degrees. Okay? Now, they don't just have to be next to each other, side by side, meaning left and right. Supplementary could also mean right here, where I'm showing you in blue. So it could be like one on top of the other, okay? Or maybe if I change my color, you can see over here, these two are also supplementary. They just mean next to each other. This doesn't necessarily mean right and left. It could be up and down the way I showed you in the first intersection. Now let's go to vertical angles. Again, just to review, they share a vertex right here in pink, okay? And they're just angles that are opposite one another. Those are equal to each other. One more vocab word to go over, consecutive interior angles. These are two angles that are adjacent or next to each other inside the parallel lines and on the same side of the transversal. These add to 180 degrees, okay, just like supplementary angles. So this will come into play with this new unit involving algebra. Let's look at our first example. We have example 1 showing 4x minus 10 in one angle and 58 degrees in another angle. Well, we need to solve for x here. So first you need to figure out the angle relationship. Well, I can see that these angles are alternate interior. Again, I draw my capital Z. The angles are on the inside of that Z. So think about, what does alternate interior angles mean? Are they equal to each other, or are they supplementary? Well, the answer is that they're equal to each other. So over here, you're going to set the angles equal to each other. 4x minus 10 equals 58. Here, you can see that we added 10 to both sides. Forgive my my scribbly writing, I'm using my finger, leaving us with 4x equals 68. Then divide by 4, and you get x equals 17 degrees. Let's try the next example. 3y plus 53 and 7y minus 55. Again, let's recognize what is the angle relationship here. Well, we're on the outside of the parallel lines, and we're on opposite sides of the transversal. So this is an alternate exterior angle. These angles are equal to each other. So just like the last example, set both sides equal to each other. 3y plus 53 equals 7y minus 55. Now the work isn't shown here, but it's clear that we subtracted 3y from both sides, giving us 4y. Okay, those cancel. And then we also added 55 to both sides, canceling those, giving us 108 on the left. Now you have a one-step problem. 108 equals 4y. We need to isolate the variable. Sorry. Let's isolate that variable. 108 divided by 4 is 27 degrees. That is your answer. Let's try the next example. Same side interior angles. Well, I told you here what kind of the relationship we have going on. Same side interior angles. Okay, and think about that. They're on the same side inside the parallel lines, same side of the transversal. These will be supplementary. These will add up to 180 degrees. Okay, so we have 66 plus angle 2 equals 180. Well, let's take away or remove 66 from both sides. And we're left with a measure of angle 2 equals 114 degrees. That is your answer. Those are supplementary angles. My last example here is 2x plus 43, and we also have a 2x minus 3. Well, I know you can see the answer right now, but if you were just given the diagram, you'd have to figure out what's the relationship here. Again, do they add to 180 or do they equal each other? They're same side interior, so just like before, same side interior adds to 180. So set both angles equal to 180. Okay, just erasing this now so you can see my work I'll do. So now we have 2x plus 2x. Let's combine these like terms. 2x and 2x gives us 4x. Okay, you can see that here. And then we have a 43 combined with a negative 3 gives us 40. All right, now we've combined like terms. We have 4x plus 40 equals 180. Now the only thing you can do here is subtract 40 from both sides. Okay, they cancel. You're left with a 4x equals 140. Now you can isolate your variable by dividing by 4, and you get x equals 35 degrees. That is your answer. I hope this helped. I can also try to do some more examples for you in another slideshow. I just didn't want to make this one too long. Please let us know if you have any questions at all. This is definitely a harder topic than last week. All right? You're all doing wonderful, and we miss you very much. Thanks for listening.